Alright, so what is more important for us to get the domain? So there are different rules for getting the domain. Okay, so let's say we have a linear function. In this case now we have a linear model. Why is it linear? This one too is also a linear model. It is linear simply because the highest power of the independent variable here is 1. So nothing is written here, but obviously nothing is written here. This is 1. Alright, so when the highest power of the independent variable is 1, then you'll be having a linear, you have a linear function. Okay, or maybe a linear model or what have you. So the line that you are going to be getting, your graph is going to be a straight line. So if this were 2, for example, then now you're having a quadratic function. So you're having a curve. So that would be like this, that would be like this. Okay? So if this were 3, your curves are not going to be like this again. Alright, maybe something like this, like you have an inflection point or something, and so on and so forth. Okay? I'm not saying that's how it's going to be, but maybe, just maybe. So here we have 1, alright, which is a linear, so we have a straight line. Alright, so whenever you have a linear function, so let's say you have case 1. Case 1, whenever you have a linear function, so how do you get? So for this, you now look at what are the possible values that the independent variable can take that will make the dependent variable to be undefined. Alright, so now let's start. Even if price were 0, even if it has the value of 0, QDX is still going to be 50. Alright, so even if price were minus, for example, let's say we're not looking at the theory. Of course, in the reality, price cannot be negative. Is either your price is 0 or you don't sell the product at all, or maybe the price is positive. So let's assume that we don't even know anything about demand, function, whatever. I'm just looking at this literally. Alright, so here, if price happens to be like minus 2, so if you're having this equal to 50 minus 2 into bracket minus 2, I think what we'll get is kind of weird. So you're having 50 plus 4, and this will give us 54, which is amazing. This means that if the price were minus 2, then you're having, in fact, your quantity demanded that is going to be greater than what it would have been if the price had been 0. Okay? So here, whether you use negative values or you use positive values or you use 0, this model cannot be undefined. Cannot be undefined. So the domain of the independent variable of a linear function is actually infinity. Okay, it's infinity. So it could be minus infinity. It's ranging from minus infinity to positive infinity. Now that is, if you draw it on the Cartesian plane, the line could be something like this. Alright, so this is where you have the negative infinity. You have negative values of x here, you have negative values of y here, and here you have positive infinity. Alright, when you sketch the graph ordinarily, it will just be something like this. But you know, when you bring this down to enter this region, so it could be something like this as well. Something like this. So you just have, it could be positive, or it could be positive, or it could be negative. So that's just it. So alright, so that's just it. So the domain of Px is any real number, okay, that are between negative infinity and which is just telling that price can take on any value, and that will not make quantity demanded to be undefined. Okay, it's not making this model to be undefined. So whenever you have a linear function, okay, the domain of the independent variable is infinity. Alright, it's all real numbers, any kind of real number that you want to put 1, 2, 3, 4, 5, minus 7, minus 50, minus 1000, whatever it is, this is not going to be undefined. So that's just that about that. Now, what if you have, okay, I think what if you have something like a fraction? Okay, what if you have a function like this, QDX equals, let me say, 50 over Px, for example. Okay, for example, let's say we have 50 over Px. Alright, so let's just assume that this is what we have. So here, what kind of value will Px take that will make this to be undefined? Actually, it is 0. So when you have a fraction, whenever you have a fraction, okay, the denominator must not be 0. If the denominator is 0, you are going to be having an undefined equation or an undefined model. Alright, so if you have 50 over 0, you can watch it, you won't be able to get any answer. 1000 over 0, infinity over 0, anything divided by 0. So this means that the domain of Px is all sort of real numbers except 0. Except 0. So here, whatever value that Px is taking must be greater than 0. PS can be greater than 0 and PS can be lesser than what? 0. But it cannot be equal to 0. PS cannot be equal to 0. Alright. So which means that we can just set an interval, let's say -1 to -5, let's say 5 to 20, 5 to 50, something like that. So your price could be 5, 10, 15, 20, 25, like that to 50, could be 100, 200, 300, whatever it is that you want to make it to be. Just do not include 0. So whenever you have something like this, okay, a model is expressed as where it's independent variable is expressed as a fraction, kind of. Okay, it must not assume 0. Alright, so once you know this, that okay, the domain of PS cannot assume 0, so that's already gives you an idea of the other kind of values that you can use, and immediately you can start to guess. If P1 is 1, what will PX be? 50 over 1, 50. Okay, so you are getting your range automatically. If PX were 2, 50 over 2, 25, you are getting the range, okay, respectively as you are getting your domain. Now there is also a third example. So let's say we have f of r. F of r is okay. Let me say we have y equals f of r equals root 2r minus 200. Alright, so this is a case 3. Alright, so whenever you have everything that is inside the root is called a radicand. Alright, a radicand, something like a radical. Okay. A radicand. So what will make your root to be unsolvable is if you have a minus. So let's say you have minus 50. You can't solve this. You can punch it into your calculator. Minus 50 minus 100, no, it's going to be undefined. So now, what must not make the value here to be negative is what you'll be looking at. The value can be 0. The value can be greater than 0, but it must not be negative. Okay? What you have here can be the domain of. Okay, now let me tell you, let's look at how it works. So here we see that 2r minus 200 must either be greater or equal to 0. So this will determine what our domain of r is going to be. Alright, so from here we'll be having 2r, this is just inequality, this is 0 plus 200, right? Then 2r greater or equal to 200. Then r, when you divide both sides by 2, r must be greater or equal to 100. Alright, so which is telling that the domain of r is value starting from 100 onwards. Value starting from 100 onwards. Now let us look at it. If r were 0 here, for example, okay, if r were 0, so we are having roots. If r were 100, we are having roots 2 times 100. Minus 200, alright, which will be root 0. I think root 0 should be 0. Alright, so that is, you can solve that. But now let's assume that this is greater, this is the rule. So this is greater or equal to. So let's pick a value that's lower than, that is disobeying this rule. So let's say we assume 98. Okay, we have 2 into bracket 90. Let me just say 90 minus 200. So we are having 180, root 180. Minus 200, and then that equals root minus 20, and you'll be able to solve this. Alright, so that's just it. So once you have an idea of this, that okay, r must be greater or equal to 100, that means your domain for r must start from 100. Okay, 100, 101, 102, 103, whatever, or 100, 200, 300, whatever, or maybe 500, 600, it must just be either equal to 100, starting from there, or greater than 100. Alright, so that is it whenever you have a kind of root like this. Now, the third scenario is where, okay, is there a third? Okay, I think I've already explained it. Okay, but let's say you have y, let's say you have y, let me say you have q is equal to, q is a function of p, q is a function of p, but then q now happens to be equal to ln p plus 10, for example. Now, what is going to make this to be undefined, alright, is if p assumes a value of 0 here. So, because ln 0 cannot be solved, you can put that in your calculator. Alright, the 0 cannot be solved. So for so that means the domain of P here must be a value that is greater than 0. Alright, P has to be greater than 0. How about being lesser than 0? I didn't really look at that. Okay. Alright, so for this, P can be greater than 0. In fact, P can be lesser than 0. Alright, but when you punch, let's say, when you say P is lesser than 0, that P can take on a negative value. So now you have like the minus 10. Alright, put your calculator, there will be a solution, but then you could be having like I at the end of it. Alright, but at least it's not unsolvable. Alright, so here, P must not take the value of 0. So once you know that, okay, that has defined your domain for you, and then your domain will eventually make you to know what your range of values will be. Alright, so now let us just quickly sketch like two graphs. Okay, let me continue from here. Let me continue. Continue from here. So when Px equals 0, we got Qdx as 50. Okay, so kind of something like this, like the table. When this was 0, this is 50. Okay, what if this were 10? Right now, this one can take this kind of linear equation. This linear equation can take on any value. When P is 10, if this is 10, so what you just have to do is 50 minus 2 into bracket 10, which is 50 minus 20. Okay, and this will give us 30. So you then have 30. Alright, what if QD were EPS equals let me say 25. X equals 25. Okay, so you're having 50 minus 2 into bracket 25 is going to give us 0. This will give us, so when this is 25, okay, that will give us 0. So if price should rise beyond that, right, which in reality cannot happen, but in theory, let's just continue with theory. Okay, so if price will, let me say 30, so you'll be having Qdx, okay, equals 50 minus 2 into bracket 30. Now minus 2 times 30 is minus 60, so you'll be having 50 minus 60, and that equals a minus 10. But according to the value cannot be negative, right? So this is just in theory, this is just telling us that this cannot. In theory, just assume that we don't know anything. Okay, let's just say literally, not in theory now. Literally, we don't know anything between price and quantity. We are just kind of playing with numbers and what have you. So we have things like this. But theoretically, we just know. Theoretically and realistically, we know that price according to the market candle was negative. So if this were a firm producing something, for example, 25 would be the maximum price that it can charge because the other things being equal. Okay? And even at 25, according to the market will be 0. So it won't even charge a price that's equal to 25. That won't get to this point. So plotting this out, when Qx is 0, okay, I think, so let's just do as we don't. I made Q here. Price is the independent variable, right? So price is the independent variable. So we have P here, and then we have quantity demanded Q. Let me just say here you have Qdx. Okay, on this axis. Now this is not what we draw normally, but I'm just so that I won't confuse you kind of. So when Px is 0, quantity is 50. So let's say 50 could be here. 50. So you have this point. Alright. So when Px is 10, 0, let's say okay, 10. This is 20. Where do you get to? 20, 30. So you can say 5, 10, 15, 20, 25, 30. Alright. So looking at the range of this, we just make this 10, 20, 30, 40. So here we like here is 0, here is minus 10. Okay. So when this is 10, we'll be having 30 of these. Until we have this point. This is where price is 10 and quantity is 30. And then when this is when the price is 25, when price is 25, we have quantity being 0. So they intersect at this point. Price is 25, quantity is 0. When price is 30, quantity is minus 10. So this is minus 10 here. So this and this are intersecting here. Alright, so we have this curve. So we can sketch this. It's not a must that it hits all the points. Alright, so we can sketch this way. Okay, so you can see. So it's going to be a straight line. Alright, so it's going to be a straight line. Okay, bring it down. So that's it. So this is how to sketch it. Now, so like I told you that it's a linear function, so we are going to be having something like that. So what if we had something like quadratic equation? So a quadratic equation would be y equals a function of x, okay, which is, let's say, as squared plus bx plus c. Okay, alright, so here, let's say we have this, instead of this being x, it's price. So y here, this is q, which is a function of price, okay, which is then equal to, let's say it's 5p squared, okay, plus 3p plus c. This is kind of absurd because okay, let me just say this is a supply function now. A supply function. Why is that the case? Because there is a positive relationship between price and quantity. There's a positive relationship between price. So what you have is plus the coefficient of price p squared here is plus 5. The coefficient of price here is 3. So there's a positive relationship between price and quantity that is here. Alright, so that's telling us that as price is going up, quantity is going up, and that happens for supply or abnormal demand. Okay, so here we are just trying to plot the graphs out. So when, okay, let's say this one is like 20. Okay, so when P is even for this, if this were 0, this were 0, what will make this one modify? This is 0, you still get 20. Right? This is solvable, so that means price can take on any kind of value. So you have P. If P were, I wish I had solved this out. If P were, let me say 0, Q would be 20. If P were 5, Q would be 5 times 5 into bracket 5 squared plus 3 into bracket 5 plus 20. So 5 times 5 is 25. Okay, this is 5 times 5 is 25. 5 squared is 25. Times 5 is 125. Plus 15 plus 20. This is going to give us 160. Okay, so Q will be 160. So let's say price were minus 10. If price were minus 10, and Q would be Q equals 5 minus 10 squared plus 3 into bracket minus 10 plus 20. Okay, so this will give us 5 minus 10 squared is 100. That's minus 10 times minus 10. Then plus 3 times this is minus 30 plus 20. So you have 500 minus 30. That's 470 plus 20 equals 490. Alright, so even when Q was negative, you still kind of have a positive quantity. So sketching that out to give us this. Okay, so when P was 0, so we have P. What function are we using? We are using this function, right? So P here is the independent variable. So we have P here, Px, we have Qx. So when Px were 0, Qx was 20. Let's look at the value of 20. So you have 20, you have the value of Q, you have 20, we have 160, we have 490. Oh, that's a lot. Hang on. 100, 200, 300, 400, 500. Okay, so this one is like minus 100, minus 200, etc. And what are the values of P that we're using? We use 0, 5, 10, minus 20. So I could just say like 5, 10, 15, 20, minus 5, minus 10, and so on and so forth. So when P was 0, Q is 20. So when P is 0, Q is 20. So kind of very small here. So it will be just like this point. Okay. And when P was 5, Q happens to be 160. 5, 160. Something like here. Alright. And when P was minus 10, okay, that was 490. When P is minus 10, then we have 490. Minus 10, we have 490, something here. Okay, something close to 500. From here, ordinarily, you can see when we continue to plot out the points, you can see that we are likely going to be having something like this. Okay. So you see, so whenever you have a quadratic function, you will have something like this, you will have something like this. Alright, so the same thing, let's say you have the quantity being a function of, let's say, 5p e raised to power x. Now, e raised to power 1 has a value. So what it does have to do is, it will be altering, okay, let me say e raised to power p. Okay, e raised to power p. So what you have to do is be altering the value of p. So when p is 0, alright, we'll be having q equals 5 e raised to power 0. Alright, give you something. Then when q is when p is another value, you have a q and so on and so forth. So that's just how this goes, and then you got to be able to like sketch your graphs and so on and so forth. So that's the graph for this particular class. Like I said, the class is a tool, okay, to whatever thing that you'll be doing in the future. So in your assignment, so the assignment is not going to be like this video. It depends on the particular period that we have. So in the assignment, in the class, I will give you assignments that you can attend. Alright. So thank you very much. I think the class is already too long. Kind of no, sorry if it eventually gets broken into part 1 and part 2. Alright, so that's about that. See you in the next class. Thank you.